All right, so for this video, we're going to be looking at the square root functions, and we're going to be talking about the transformations that we're able to identify, not only kind of looking at it on a graph, but also really looking at the equation and looking at the rules that you have to memorize in order to identify these transformations. So the parent function of a square root obviously is y equals the square root of x, but we may have some transformations that are going to get applied to being multiplied. We may do some adding and subtracting inside here, and we may do some adding and subtracting outside the function. So when we look at the transformation, you can see that the square root of x, that's the parent, and then we have some values that are being added, subtracted, and multiplied here. So the first transformation that we're going to look at is what happens if I have a number that's outside the square root and it's being multiplied. Well, there's a couple of things that actually can happen, and we're going to split this into two separate pieces. So this a value, if the a value is greater than 1, we call that a vertical stretch. So if you think about like slime and stretching it vertically, it's actually going to make it look skinnier, but it's stretching the y values and they're getting bigger, I guess you could say, as the x's are smaller. So if the a value is greater than 1, it's a vertical stretch by whatever the a value is. That's called the scale factor. If the a value is greater than 1, or excuse me, less than 1 but greater than 0. Now there's a reason I have greater than 0, because if it is less than 0, we're going to actually apply the negative as a different transformation. So if my a value is greater than 0 but less than 1, then we call that a vertical compression or shrink by the a value, and that should be a right there. So when I'm looking at the a value and I'm thinking about the y values getting smaller, that means that it's going to be compressed down like we're pushing them together vertically. Now, it also is going to change the shape of the curve. So like a square root function technically is like it starts with what we can kind of call like the vertex point, and then it's going to go off to the side in either direction. But what happens if that value has a negative in front of it? We're going to separate that number, that negative, from the a. And basically what's going to happen is if I have a negative number with the a, that negative is actually going to cause a reflection, but it's a reflection over the x-axis. So just to kind of give you a visual here, so we have y equals the square root of x, and there's our basic parent function. So I'm going to adjust this by turning off the minor grid lines and then putting the steps as a 1 and a 1, so we can kind of look at it one unit at a time. So you can see we have 0, 0, we have the point 1, 1, another perfect points at 4 and 2, and then so forth. Now, if I have a number that's being multiplied in the front, like let's say greater than 1 would be 2, so 2 square roots of x. If you look, it's actually a vertical stretch. So why is it a vertical stretch? Because the y values are going to be bigger with that x value. So right now, the x value at 1 gives me a y value of 1. But the x value at 1 for the new one is actually giving me a value of 2 because we're multiplying the y values by 2. So right here we had a x value of 4 that gave me a y value of 2. But at the x value of 4, we now have an x value of 4 because it's being multiplied by 2. So we're vertically stretching the numbers. So the y values are getting bigger. All right. And then what happens if it's less than? So let's say 0.5 times this, well, back in. And then we have the square root of x. So if you notice, we're compressing it this time. And the reason that is because for every x value, the y value is actually smaller than it was previously. So at 0, 0, obviously that's going to be the same. But at 1, we initially, in red, had a value of 1. But now at 1, we have a value of 0.5. Okay, because we're multiplying it by 0.5. All right, so at 4, we initially had a value of 2, but now at 4 we have a value of 1 because we're multiplying it by 1/2. Remember, multiplying it by 1/2 is the same thing as dividing it by 2. So we're decreasing the y values and how big they're going per x. Now, the other option that we have is the negative. So if I have a negative in front of my square root, So there's my parent, and then we can see that reflection, that reflection over the x-axis, okay? So what happens, so we had this 2 and it gave it a vertical stretch, but what happens if I have that negative in front? It's still going to cause that reflection, it's still going to be vertically stretched, but it's causing it to reflect over that line. So that's the reason we separate the A value and the negative, is so we can identify those individually. And we can say, okay, we did a vertical stretch, but then we reflected it over the x-axis. So make sure to separate those when you state your transformations. All right, the next transformation that we're going to look at is if we have a number being added or subtracted inside the square root with x. Now, I always say for these, x's are crazy. Like if you think about it, ex-boyfriend or ex-girlfriend, you broke up with them for some reason. At some point, they were crazy enough that you didn't want to be boyfriend and girlfriend anymore. The reason that they're crazy is not necessarily because they are, but because the original format has a subtraction sign. So right here it says if h is positive, it's going to the left, because technically, if we think about it, if we go to the left, we're putting in a negative number. Well, if I do a negative negative, it's going to actually change that into a plus. So when you see a plus, it's the opposite of where we think it's going. So a plus h means we're going to the left h units. So if I have a negative h right here, the formula or the original formatting is already negative, but we normally think of negative going to the left, but because it's already got that subtraction sign there, it's actually going to the right. So again, if I go back to my graph, so there's my original, and I have the square root of x. So let's start with minus 2. So you can see that we started at 0, 0, and we shifted 2 units to the right. So even though it was minus, the minus was already part of the original standard form. So that 2 is actually meaning that we're going to the right 2 units. Now, normally we would think of plus as going to the right, but because we had to shift and there was a minus sign there, it technically was minus a negative, which caused us to go to the left. So you always got to think about what's in the side with x is crazy. So always think opposite. So if I have plus 2, that means I'm going to the right 2 units. If I have minus 2, that means I'm going to the left 2 units. So just keep that in mind. And then finally, we have a value that's going to be added or subtracted, but this value is outside of the square root. Now, this value is not with the x, so this is normal of what we think, and it's going to cause it to go up or down. It's a vertical shift. So if my k value is positive, that means we're going to shift up that many units. If my k value is negative, that means we're going to go down that many units. So again, if I have the original parent function and I say I'm going to go up plus 5, you can see that I started at 0, 0 and I shifted up to 0, 5, so I went up 5. If I say that minus 5, and again, just keep in mind that it's not inside of the square root. We start at 0, 0, we're now going down to 5. So we can have all types of transformations all in one problem, and we can see that it transforms. So this one, we'd have a vertical stretch by 2. We'd have a reflection over the x. We'd be going to the right by 2 and down by 5. So what we're going to look at is how to identify each of these individually and state what the transformations are. So normally what I like to do is technically we would do what's inside the square root. Then we would say what's being multiplied by the square root. And the plus or minus that goes up or down is always the last. So I'm going to start with the minus 2. Now this minus 2 right here is telling me, normally we would think minus would go to the left because inside is left or right. But remember their x's are crazy, so we're actually going to the right by 2. So we're going to be going to the right 2 units based off of the minus 2. The 3 is being multiplied in the front. So 3, this is greater than 1. So that means that we are going to have a vertical stretch. And that vertical stretch is going to be by our times 3. So we're going to be multiplying those y values times 3. And then finally, we go to the back, which is always the last part, the up or down. And the back part, the plus 1, is telling me to go up 1 unit. Okay. So in the next one, same situation. I'm going to start on the inside on the inside of my square root, I have plus 1. So normally we think plus is right, but it's the opposite. So we're actually going to be going left 1 unit. Then we have this 1/2. This 1/2 is being multiplied in the front. So 1/2 is actually less than 1, but greater than 0. So this is going to be a vertical stretch, a vertical shrink or a vertical compression. Either word can be used. They're interchangeable. Some questions use one word and some use the other. So just make sure that you know shrink and a compression are by the same thing. So we're going to say it's going to be a vertical shrink by 1/2. And then finally we go to the back and we see that we have -3. So -3 means we're going to go down 3 units. Okay. All right, so for this one we got actually 4 transformations because we do have that minus sign in front, and we are going to separate that because that's going to show a reflection where one is going to show like a stretch or a shrink. So we got -2, so remember that's the opposite, so we're actually going to go to the right 2 units. And that doesn't matter which one you state first here, because, you know, we've been doing the inside, then the front, and then the back. It doesn't matter which one you state in order. They're all going to be in the same spot. So this negative in front means that we're going to have a reflection of the function, and it's going to be a reflection over the x-axis. All right, so when I have that reflection over the x-axis, then we're going to be looking at the 7/3. Now, 7/3 is an improper fraction, so actually that is going to give me a vertical stretch because it is greater than 1. Even though it's a fraction, it's still improper, which means it's larger than 1. So this is a vertical stretch, and it's going to be a vertical stretch by 7/3. And then finally, the last one is always the plus or minus at the back, which means we're going to be going up 8 units. Now, if you notice in here, we don't have a plus or minus this time. So we're not going to actually be shifting left or right. So we're going to go straight to the front, and we have, once again, we have a negative and we have an A value that is negative. And that A value, we're going to say is greater than 1 because we're separating them. So that's going to be a vertical stretch by 7. All right, and that vertical stretch is then going to be applied with the negative, and that negative is going to cause it to be a reflection over the x-axis. And after we reflect it over the x-axis, then we're going to go to the k value, which is the outside of the square root, and it's positive, so that means that we're going to go up 8 units. Now, again, these rules are just something you're going to have to memorize. Once you memorize the rules, it really and truly is just about looking and stating what transformations you see. And you can always verify those graphically. Just like I said earlier, we have the original. We said that in that square root of x, we were going to have a reflection over the x-axis. So I can look at the negative and see that is a reflection. I can also say I'm going to do a vertical stretch. So we're stretching the y values vertically. And then finally on the outside, we're going to go up 8. And then, of course, it shifts up 8 units. So you can always verify that you got them right and look at it like individually, piece by piece in Desmos. All right, let me know if you have any questions on this.